Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox. Today, we are looking over the equations for proportional relationships, and I'm going to try to keep this short and sweet. It's not too difficult, so let's just kind of dive right into it. The equations for a proportional relationship, we're going to start with the standard equation for a proportional relationship, and that's y equals kx, all right? Where y is your dependent variable, k represents a constant of proportionality, and x is the independent variable. All right, so whenever we know what x is, we can multiply it by the constant of proportionality, and that's going to give us our y. Therefore, we know that y is dependent upon whatever x is. All right. And it varies directly with that. So it changes directly in sync with whatever your independent variable is. All right. So the dependent variable depends directly upon the independent variable. All right. Another way to kind of think about that is the output y is going to vary directly with the input x. All right. Such that if we took our constant of proportionality and we said, okay, we're going to make it a 3. All right. We're going to substitute that. And we decided to create a table of numbers here of input and output values. Let's say we input 2 for x. Well, if I input 2 for x and I multiply it by 3, I'm going to get an output of 6 for y. All right? If I input 3 for x, I'm going to get an output of 9 because 3 times 3 is 9. If I input 4 for x, I'm going to get an output of 12 for y. All right? Do you see how whatever value I create for x directly affects the value for y, all right, the value for the output, all right? So that's why we say that y is dependent upon x, all right? X is your independent value, and then whenever you plug that into the equation, that's going to determine what the y variable is going to be, all right? So it's dependent upon that. All right, so that's all going to help us in being able to kind of identify some of the words that might be used in word problems to be able to represent really this part right here, the equals k, all right? So some of the words that you might see in word problems, though these are not all of them, but maybe you can kind of use these to be able to help you understand some of the other words that might be put in there. But one of the words you might see is the word proportional, all right? Proportional is not a word we use a whole lot in everyday life, but you see it, a fair amount in math word problems. And that's because, we want our students to understand the idea of proportionality, that you have kind of two different variables that have a relationship with each other by multiplication. And whenever you change the quantity of the independent variable, the dependent variable is going to be changed directly in sync with whatever the value is of the independent variable. So you've got these two different variables that kind of are synced together. And an example that I have been using in some of my videos is, one apple is 50 cents. Okay? That's about how much an apple. No, it's probably more like $1 these days, $1.50. But anyways, back in the olden days when I was a little boy, one apple was 50 cents. All right. Well, these two amounts are tied together. All right. One amount directly affects the other amount. All right. Such that if I had 4 apples, all right, that value now is going to directly affect how much money I'm going to have, the total cost. So the total cost is going to go up directly in sync with how many apples I get because these two amounts are linked together. All right, that's my wife calling. All right. Okay, so the words that we might need to understand are the words is proportional to, and the word varies directly with, all right, or changes in sync with the other values. So let's just try to understand these, all right? When you see that word, those words is proportional to. The words is proportional to can be represented with the equal sign, that's the word is, all right? And then the K, The K represents the constant of proportionality, which every proportional relationship has a constant of proportionality. All right, so the words is proportional to could be represented with an equals K. All right, and then the variable that comes before the words is proportional to is going to be your dependent variable, because it's going to be the variable that's determined by whatever the independent variable is. And then the variable that comes afterwards is going to be your independent variable, just like that. All right, so the words is proportional to gets us our equals K, and then the variable that, the variable that's in front of the words is proportional to will be our dependent one, and the ones that come after is going to be our independent one. All right, and then the words varies directly with, all right? The words varies directly with can be substituted for the words is proportional to. So you don't see the word is, that's like a dead giveaway for an equal sign, but you see varies directly with. You're saying that Y is directly tied to the X, all right? And there's going to be a relationship here such that if you increase X, you're going to have to increase Y, all right? It naturally increases the other one, all right? So varies directly with gets us our equals K, all right, is proportional to, and the words that come before that represent, or the variable that comes before that represents your dependent variable, and the words that come after that represent your independent variable, just like that. So here's kind of an example of what I'm talking about. This graph shows Robert's candy consumption, and you see over here in the y-axis you've got the actual candy that he's eating and how it's going up, all right? And then over here on the x-axis you see the number of days represented, all right? And as the days increase, so does the candy consumption. So you see this graphed line is kind of moving up in two different directions. It's moving up to the right, if you will, and it's moving up towards upwards, if you will. All right, so it's increasing the days, and when we're increasing the days, we're also increasing the number of candy that's been consumed. All right, such that after 1 day he's eaten 16 pieces of candy. After 2 days he's eaten 32 pieces. After 3 days he's eaten 48, and so on and so forth. All right, so you've got the number of days increasing and the number of candy that's increasing as well. So the number of candy he's eating is determined by the days that have gone by, or the days are determining the candy consumption. All right, or to say it another way, candy is proportional to the days being spent. So we can write this equation as is proportional to, that's going to be our equals K, and the candy is directly tied to the number of days he's been eating. So such that if we found out, we wanted to know, well, how many pieces of candy is he eating in 13 days? Well, we have to find the constant of proportionality. I'm just going to give it to you. That's not the nature of this video, but it's 16, all right? Then you would just have to multiply 16 times 13 to be able to find out how much candy he's actually eating. So the number of days he's been eating times how much he eats every single day tells you about the total candy that he's eaten. All right. So let's go on and let's try to write some of these equations given a scenario, a situation. All right, so we've got, write an equation for this relationship. The amount of money spent at a store is proportional to the number of items bought. And I see my key words right there, is proportional to. And I know the words is proportional to can be represented by an equals K, all right? That's saying is, and constant of proportionality means that there's a proportional relationship. So this is proportional to, all right? Now then, I'm going to have to create some variables because my problem didn't give it to us. So I have to think about what variable came in front of the word is, all right? You see the word is right here. You've got in front of that, it says the amount of money spent at a store. So let's just look like key in on the key word right there, the number of money spent, and we're going to create a variable for it, which is just the first letter of the word. That's an M. That's going to be our dependent variable. The total number of money, or total amount of money that's being spent is going to be directly affected by how many items we're buying. All right. Now then, what comes after the word is proportional to is going to be our independent variable, all right, which is going to represent whatever the words are to the number of items bought, all right? So we're going to have to, after the word is proportional to, the words, the number of items bought. So however many number of items that are bought is going to affect the total amount of spent. So we're going to create a variable for number of items. And I just used the letter N. You could have used the letter I. That's just fine. But in this case right here, we would have M equals Kn. So the total amount of money spent equals whatever the constant of proportionality is multiplied by the number of items bought, or whatever the cost of each item is, all right? Now then, I want you to try this next one by yourself, all right? You're gonna have to create variables for the two different variables in the problem, the things that are being linked together, and then you're going to have to represent this in an equation, all right? You're gonna wanna start with the standard equation for proportional relationship, and the reason why is you're looking inside the problem, you're seeing words that kind of jump out as key words for representing proportional relationships. And that's the words varies directly with. The word varies directly with says that one quantity, all right, is directly tied to another quantity. And as this quantity raises, so does this one. Or if this quantity decreases, so does the other one, all right? So they vary directly with each other, all right? They're in sync with one another. So the word varies directly with tells us we have a proportional relationship, which is going to be represented by an equals K. There's a proportional relationship. Something is equal to something else multiplied by a constant proportionality. Then we got to find a dependent variable, which is going to come before the words varies directly with, and that's the number of people. So I'm going to use that as represent that with a P. The number of people in a city varies directly with the amount of pollution, all right? I could create a P for pollution, but we don't like to have the same variable that represents two different things in the same equation. So I'm going to use the variable A for amount, all right? And we're just going to put it like that. So we have the number of people in a city varies directly with, is proportional to the amount of pollution that's going to be there. So, there we go. Why don't you try this one? Go ahead and pause this video. You try to write it yourself, then I'll come back and tell you what the right answer is. All right, it says the total cost, C, of a purchase is proportional to the number of items in purchase at a constant price, P. All right, so you've got equal sign K, all right? We're just going to write everything out. Y equals KX, all right? The is proportional to is the equals K. Then the words that come before that is total cost. Total cost, by the way, is always a dependent variable, always, all right? And that is proportional to the number of items in purchased, all right? And then it says at a constant price P. So they threw another variable at us, which it doesn't happen very much, all right? Really, you're actually given numbers usually to find the constant of proportionality, which is going to be the nature of the next slide here in just a second. But we're going to take that P that they gave us as a variable, and we're going to represent our constant of proportionality in the problem, which is the K, with that P. And the reason why we know to do that is we see that keyword constant, all right? There's a constant price, a constant rate, which represents a constant rate of change, or is also known as the constant of proportionality. So we should have C equals P times N, all right? And the great thing about this word problem is they gave us the variables in it, all right? We didn't have to create them on our own. All right, now let's get to some word problems that have numbers instead of just variables for the constant of proportionality especially, all right? Look at this first sentence. It says, the amount of sugar used is proportional to the number of cookies made. Now I want you to stop right there, and I want you to write an equation starting with your standard equation for a proportional relationship, because we see the key words proportional to, right? I want you to start with a standard equation for a proportional relationship, y equals kx, just like that, all right? Then we're going to go to the problem. It says is proportional to, that's going to be the equals k, all right? And the variable in front, let's use these two variables for our variables. The amount of sugar, S, sugar S is going to replace our dependent variable, all right, is proportional to the number of cookies made. Cookies made is going to be our independent variable, all right, or our x. Right? So far we should have that as an equation, all right? Just from that first sentence, the amount of sugar used is proportional to the total cookies that you can make, all right? Or the total cookies that are made, all right? And then the second sentence says, if 3 cups of sugar are used to make 20 cookies, find an equation that represents the total cups of sugar for making any amount of cookies, all right? Well, now we're being given numbers, and the numbers are going to give us, we're going to use those numbers to help us give us our constant of proportionality, the price that is being multiplied by the independent variable in order to be able to determine the dependent variable. Or in other words, the price, the number that's being multiplied by our input in order to get our output. All right, and we see 3 cups of sugar are made, makes 20 cookies. Well, we need to come up with this K. All right, which means we need to remember the formula for, or the equation for, a constant of proportionality, which is constant of proportionality equals your y variable divided by your x variable, all right? Your dependent value divided by your independent value. Or to say it another way, your output divided by your input, all right? And in the problem we see from our equation up here that the y is sugar and the x is cookies, all right? Remember our standard equation for a proportional relationship is y equals kx. Well, the x in this problem is the c, and the y is the s. So we could take that and put that in our equation for the constant of proportionality. Or let's replace that y with the s, and let's replace this x right here with the c. Those are the variables from the problem, all right? You're not going to use the same letters for every problem. This is just the variables for this problem, all right? And then we're going to go up to the problem, and we're going to find out what's the number that represents sugar and what's the number that represents cookies. So let's find the one that says sugar first. It says, if 3 cups of sugar. So 3 is the number of sugar that we need. So we're going to replace the S with a 3. And then cookies, there are 20 cookies. So we're going to place the 20 for the C right there, for the cookies, all right? And we're going to have a constant of proportionality of 3/20ths, all right, or 0.15. I'd like to leave it as a fraction, though, if that's okay with you. I like fractions, and so I think fractions are great concise way to be able to express a number, all right, or part of a number, part of a whole. So we can take that 3/20ths there, and we can replace our K with that 3/20ths, and now we have an equation that represents this problem, all right? All right, I want you to try this last one, okay? And I'm going to go ahead and give you the variables, P for pollution size and S for number of stores in the area. Go ahead and read the problem yourself, all right? Pause the video, read the problem yourself, all right? And try to do it by yourself, and then come back and see what the answer is, all right? All right, so you should have paused already, all right? Because I'm about to tell you what the answer is. Here we go. I'm going to start with the standard equation for a proportional relationship because, well, that's what we're doing in this video. But if I didn't know that already, then I could go to the problems, and I see the keyword proportional with, all right? That keyword proportional with, which triggers me to think, okay, I need an equation here to represent a proportional relationship. So I'm going to start with the standard equation for a proportional relationship, y equals kx, all right? And I'm going to start substituting the letters for different things from the problem, all right? It says the pollution size of an area is proportional with the number of stores in an area, all right? Is proportional with tells me I've got my equals K, and the words that come before is proportional with is pollution size, and I'm given a variable of P, so that's going to go before the equal sign, all right? Before the is in the problem. And then it's proportional with the number of stores in an area, all right? Stores S. So far, I should have an equation, P equals KS, all right? So I started with my standard equation, and I substituted the variable for the dependent value, or the dependent variable in the problem, and then the one for the independent variable. So I just replaced it in that. So P equals KS. Then I'm going to go to my second sentence. If the population of 500 people has 5 stores, find an equation that represents the population for any amount of stores. So we've started off with our standard equation for this problem, and now we need to know what k equals, all right? Which I know that the formula or the equation for k is y divided by x, output divided by input. And in this problem, the y is our population size, and the the x is going to be the number of stores in the area, because we're starting with our standard equation. We know that p has replaced y and s has replaced x. So we're going to do that inside of our little template up here. We're going to put population size is going to go on top because that's the y, and then s is going to go on bottom because that's the x. And then I'm going to go look for the numbers inside the problems to replace for the p and the s, all right? If the population of 500, so the p population in the in the problem is 500. The population is 500. Then the population of 5 people has 5 stores. All right, so that we have 500 for the population. We have for our stores the number 5. So we're going to put that at the bottom right there. And then we can simplify this. 500 divided by 5 is 100. All right, so we have a constant of proportionality that is 100. All right, so 100 stores for one store for every 100 people in the area. All right, but we can take that 100 now and we can substitute it in our equation that we had written up there for the k, and that is our equation right there. P equals 100s. All right. I hope you enjoyed this video. If you did like this video, you're always welcome to subscribe to the channel. Click the subscribe button down below. Click the like button, and I hope you have a great day. Okay, bye.